And this video is on Z Isomerism. And so our aims for this video are to be able to define stereoisomerism. So in Chem 1 you learn about structural isomerism. This is slightly different, stereoisomerism. Understand how Z isomerism arises. Z isomerism is a type of stereoisomerism which is again new to you. And recognise and draw pairs of Z isomers. So first, the definition of stereoisomerism is something you have to know. So stereoisomerism is two molecules with the same structural formula, but they have different arrangement of atoms in space. So defining stereoisomerism would be a 2-mark question. 1 mark for saying they have the same structural formulae, and another mark for saying they have a different arrangement of atoms in space. So Z isomerism is a type of stereoisomerism, and it arises due to the fact that an alkene double bond, so if I just draw an alkene, has a double bond in the middle, cannot rotate. So if you have groups around it that are different, so for example CH3, H, and then CH3 here, and H here, this double bond can't rotate, whereas a single bond could, which means that this molecule here is different to a molecule where these two groups have swapped around. So this one here. There we are. So on this molecule here, we've got the two methyl groups and the two H groups on the same side as each other. Okay? Whereas on this molecule here, we've got the H groups on opposite sides to each other and the methyl groups on opposite sides of each other. It's worth pointing out now that if you've got two groups that are the same on the same carbon, so say these two are two H's or two methyls, then you wouldn't have another isomer of it, because if you swap those around, then it would be exactly the same molecule. They have to have two groups that are different on both carbons. So these isomers arise as you cannot rotate the double bond. And you can name these two isomers. And what you've got to remember is that if the two groups are on the same side, then that is the Z isomer. So this one here is the Z isomer. Whereas if they're on opposite sides, like the one below, then that is the E isomer. Now the way I remember this is that the Z isomer have both of the groups on the same side, or the same side if you like. And that's just a way of remembering which one the Z one is and which one the E one is. So, how do we name molecules that have Z isomerism? So we're going to take an example. So for example, pent-2ene. So pent-2ene has the following structure. So we have an H and a methyl group on one of the carbons where the double bond is, and an H and an ethyl group, that's a CH2, CH3, on the other carbon. Now the first thing I would do when trying to draw Z isomers is to draw this slightly differently, and that is to draw it at an angle. So you have the double bond, and then you have the 4 groups around the 2 carbons coming out at slight angles rather than a straight line here. So if I was to draw this one here, you can see the 2 H's are on the same side here, they're all both going up, whereas the 2 carbon groups, if you like, are going outwards. So the H's would be up here, and then you've got the CH3 here, which would go here, and you've got the CH2, CH3 here, which would go here. So that's one of the isomers, and the other isomer is basically the same, but with one of these pairs of groups swapped around. It doesn't really matter which one you swap around, they'll both be the same, but it's important you only swap one of them round. So I'm going to swap these two round, and so the other one would be, again, just draw out the two carbons with the four groups around it. The other one would be the same on this side, and this side we would have them swap round. Now here, there are two groups that are the same, and those are the H groups. So we're going to base our names on the H groups. The two H groups here are on the same side. The two H groups here are on opposite sides. The fact they're on the same side here, remember that's the Z isomer. And the fact they're on different sides on the other one here, we call that the E isomer. And so this one, the Z isomer, would be called Z pent 2-ene. And the E isomer would be called E pent 2-ene. So the E or the Z goes before everything else in the name. So I'm going to finish the video off with a couple of exam questions that could come up. So here is one of them. So they give you an isomer, which is an alkene. You can see that it could have EZ isomers. And they tell you that that is E pent 3N2-ol. And they ask you to draw the structure of Z pent 3N2-ol. So you can use this to help you do that. It doesn't really matter what the rest of the name is. You may not understand what that means, but the fact you know that this is the E isomer means that you can work out what the Z isomer is. And to work out the Z isomer, all you have to do is swap one of these two pairs around. Again, it doesn't matter which one you do. This time I'm going to swap the first pair around. So the Z isomer here would be the following. Draw the two C's in the middle. We're going to leave the right-hand side the same, so CHOH. Make sure you draw it exactly the same. And then on the other side, we're going to swap those two groups around. The top is going to be the H this time, and the bottom is going to be the methyl. And now you can see the two H's on the same side, which the Z should be, and here the two H's on opposite sides, which would represent the E. Finally, this question here says, identify the feature of the double bond in E pent 3N2-ol, that is, that in Z pent 3N2-ol, that causes these two compounds to be stereoisomers. So this is like a bog standard question, which is asking about the rotation of the C-C double bond. And basically the answer here is that you cannot rotate the double bond. And it's important that you use this word here, rotate. So the fact that the double bond cannot rotate is the reason why you get these two isomers. You must use this word. I hope that helps. Please email me if you have any further questions on EZ isomerism.